Hello everyone, welcome back to the my YouTube channel. Today we are going to discuss an important topic in lean manufacturing, line balancing. What is line balancing? Have you ever noticed that in a production line some workers are overloaded while other workers are waiting with no work? So this imbalance creates bottlenecks, increases production time, and reduces efficiency. To solve this problem, industries are used for the technique called line balancing. Line balancing is the process of distributing work evenly among all workstations so that each station takes approximately the same amount of time to complete its tasks. The main objective is to eliminate idle time, reduce bottleneck, improve productivity, and achieve a smooth production flow. In this video, we are understand that line balancing is what is line balancing and why it is important, and its benefits, the steps involved, and the practical example from the manufacturing industry. So stay with me until the end of this video to gain a complete understanding of line balancing in lean manufacturing. So let's start it. So, what is line balancing? Line balancing in lean manufacturing. So, line balancing is one of the most important concepts in lean manufacturing. It means distributing work evenly among all workers, machine, or workstation so that every process takes nearly the same amount of time. The main goal is to ensure a smooth flow of production without delay, waiting time, or bottlenecks. When a production line is properly balanced, all operators work effectively, production move continuously, and customer demand can be met on time. So, definition of the line balancing. Definition of the line balancing. Line balancing is the process of assigning tasks equally across a production line so that each workstation has a similar workload and the production process flows smoothly without interruption. So, in simple word, I will explain. Line balancing means share work equally among all worker and machine to achieve maximum productivity and minimum waste. So the objectives of the line balancing are the main objectives are reduce idle time of workers and machines, eliminate bottlenecks in the production process, improve production efficiency, increase productivity, reduce manufacturing cost, meet customer demand on time, improve workflow and product quality. So why line balancing is important? So without line balancing, some problems will created. So first problem is that some workers become overloaded, some workers remain idle, production slow down, delivery delay occurs, cost increases. Cost increases with proper, suppose you do in proper line, then what will happen? Work is evenly distributed, production flows smoothly, employee efficiency improve, customer satisfaction increases. The example of the line balancing. The example of the line balancing. Before line balancing, suppose a product pass through three workstations. Before line balancing, suppose a product passes through three workstations. So station one time required for 2 minutes, station B 8 minutes, station C 3 minutes. So in this situation, station B takes much longer. So station A and C finish early and wait. Station B becomes bottleneck and production output decreases. So what will happen? So after line balancing, after line balancing, the tasks of station B are divided among all stations. So station A 4 minutes, station B 4 minutes, station C 5 minutes, and then now work is balanced. Now work is balanced. Waiting time is reduced. Production flow becomes smooth. Output increases. So benefits of the line balancing. What are the benefits of the line balancing? Increase productivity. How the productivity increase? So balanced workstation produce more product in less time. So second one is reduce waiting time. Worker and machine spend less time waiting and better resource utilization. All resources are used effectively. Lower production cost, less waste and higher efficiency, reduce cost, improved employee morale, worker experience a fair and manageable workload, faster delivery, product can complete product can completed and delivery on time. So the improve quality, balanced operation, reduce mistake and defects. And common causes of the poor line balancing and common causes of the poor line balancing: unequal distribution of tasks, machine breakdowns, lack of worker training, poor production planning, variation in process times, and material shortages. So some steps are implemented in the line balancing that will clearly you understand. Then step one, study the production processes. First, you study the production processes. Analyze each operation and workstation. Analyze each operation and workstation. Step 3, measure cycle time. Record the time required for each task. Record the time required for each task. Step 3, identify bottlenecks. Find station that takes longer than others. Find station that takes longer than others. Step 4, distribute work. Move tags from overload station to unauthorized station. Move tags from overloaded station to unauthorized station. Then step 5, train employee. Train employee. Ensure worker can perform multiple tasks if needed. Ensure worker can perform multiple tasks if needed. Step 6, monitor and improve. Continuously review performance and make improvement. Then practical example in a garment factory. So that are practical example in a garment factory. So a shift manufacturing line has 5 operations: collar stretching 2 minutes, sleeve stretching 3 minutes, pocket stretching 7 minutes, side stretching 3 minutes, final inspection 2 minutes. So what is the problem? Problem is that pocket stretching takes 7 minutes while other operation takes less time. Solution: assign an additional operator or divide the pocket stretching work into two smaller tasks. Results: the production line becomes balanced and production output will increases. So relationship between lean manufacturing and line balancing. Lean manufacturing focus on eliminating waste and create smooth production flow. Line balancing support lean manufacturing. Line balancing support lean manufacturing by reducing waiting waste, eliminate bottlenecks, improve workflow, increase productivity, supporting continuous improvement like Kaizen. Therefore, line balancing is a key tool used in lean manufacturing to achieve operational excellence. So, I'll conclusion about that. You can simply understand what is line balancing. Line balancing is the process of distributing work evenly among worker and machine to create a smooth production flow. It helps reduce waste, eliminate bottleneck, improve productivity, lower cost, and increase customer satisfaction. In the lean manufacturing, line balancing play a critical role in achieving efficiently and continuous production operation. So this is the my first part of the line balancing. I will explain in the second part. You can clearly understand about that what is line balancing. So this is the my second part of this video of the line balancing. You know what is line balancing? So you can see that image, then you can clearly understand what is line balancing. So let's start. See that first image. So see machine 1 machine capacity 5 pieces per hour. Then C2 machine capacity 5 pieces per hour. C3 5 pieces per hour. C4 5 pieces per hour. And B1 machine 10 pieces per hour. And B2 machine 10 pieces per hour. And machine A capacity is 20 pieces per hour. So what is the difference in line balancing? See that I will explain it clearly. So first line balancing. Line balancing is to match production rate to takt time. So what is takt time? Available time by customer request. Available time by customer request. So line balancing is the match of production rate to takt time. Takt time equal to available time by customer request. Our aim to make cycle time of all the workstation almost same. Our aim to line balancing. Our aim to all the our aim to make cycle time of all the workstation almost same. So how do we define a balanced line? No one overburden, variation is smooth, no waiting time. So keep that one example. I will explain one example, then you can clearly understand about that. So my machine A capacity is 20 pieces per hour. You will make it. So production overproduction inventory. Overproduction inventory 20 pieces. My machine B is 10 pieces per hour. Machine B and my machine C is 5 pieces per hour. So my machine A is overproduction in inventory. Machine B is waiting overproduction inventory. Machine C is waiting. So this one is the unbalanced. So A, B, C are all balanced. So what will happen in a 20, a 10, 5? So that will be unbalanced. So how to balance? So one example, see that example. Customer demand is 160 units per day. Calculate first takt time. Total working hour a day 8 hours. So takt time equal to 160 divided by 80, 20 units per hour. So some steps are calculate takt time, identify bottleneck operation, relocate resources. So see that image. So 20 machine A capacity is 20 pieces per hour. Machine B and C. So that will be balanced 20 pieces per hour. So machine capacity. So I will divided with the share A B C. A B will divided in 5 5 5. So machine C1 is capacity 5. C2 is 5 pieces per hour. C3 is 5 pieces per hour. C4 is 5 pieces per hours. So that one I will balance it. C1, C2, C3 and C4. So, and see that image I will balance it with the zero waste. Balanced with the zero waste. And then what is the benefits of the line balancing? Reduce waiting time, reduce inventory waste, internal and external irregularities, reduce production cost and increase profit. So this is all about for me my part 2 video. So I will explain it clearly. So let's start about the part 3. What is line balancing? And the agenda of the part 2 my course. So course agenda is first introduction. What is line balancing? Where do we use line balancing? Example, line balance. A simple example, prerequisite for line balancing. The benefits of prerequisites, methods, visual management, summary and flowchart. So one by one details I will explain about it. What is line balancing? So introduction. First introduction. What is line balancing? Everyone is doing the same amount of work. Doing the same amount of work to customer requirement. Variation is smooth. No one overburden. No one waiting time. Everyone working together in a balanced fashion. So what is line balancing? See that image. Why should you balance the production? So in large batch quantity, line not balanced. So see that. So introduction to line balancing in single piece flow and well balance in single piece flow and well balanced. Then example of a line balancing chart. This is the visual production tool that enables the planning and organization of individual and timed items of work to create the foundation for a balanced production line. So it is used as a tool to continuously drive out waste from operation and processes, and it is also valuable tool in implementing changes in customer demand. Then line balancing in simple example. So the overproduction which causes the other six waste. So see that on first one image you can see first person 5 minutes, then second person 25 minutes, third person doing work in 15 minutes, fourth person doing work in 10 minutes. So that one will manage will very difficult. Then second one customer constraint overburden. Then the third one is this operator must wait for operator 2, and the fourth one this operator must wait for operator 3. So everyone will be interlocked. So over processing, inventory waiting, reward, transportation motion. That one six other wastage in production line. So in line balancing, that one simple example. So promotes one how to simplify promote one PC workflow, avoid overburden, minimizes the seven waste and reduce variation, and distribute first last image, see that gap, distribute the work one by one, then automatically line will balance. Then prerequisite to line balancing. Request first calculate Takt, understand the drumbeat of the customer. So standardize, achieve consistency in operation, enabling us to achieve our customer requirements by managing our production effectively. Variation in our operation demand more than human intervention, which increases the risk of human error. Then takt time. Takt time is a German word. So the takt time is a German word. It describes the metronome. It is the principle that all activity within a business is synchronized by pulse set by the customer demand. Takt total time available divided by total customer demand. Then takt time, customer demand 10 units per month, total time available 20 days. So takt time equal to total time available divided by total customer demand. So drumbeat one part every 2 days. So each process need to complete one unit every 2 days. So every 2 days one process, every 2 days one by one process. So then automatically 1, 2, 3, 4, 5. Then five passes will be completed. Then customer also send that packs. So standardize. One more standardize. Standard work layout. So which capture the layout. So the pre must be worn at all times. Pre must be worn at all times. So we indicate how the workflow highlights the information. So stores workstation one, tool cabinet workstation two, and then workstation three. So this one, two, three, you can complete layout means idani easily understand in operator or any staff. Then one by one, everyone do in your work one by one. So one more standardize workstation sheet. So you can maintain this type of work sheet. Then automatically line will balanced. And the benefits of the prerequisites. The benefits of the prerequisites, takt time, standardized operation. What do you think are the benefits? The benefits of the prerequisites, takt time maximizes the productivity due to easily managed processes. Output of each process matches customer demand. Standard operation provide capable all repeatable processes. Process control at sources. Improve accuracy of planning. Better adherence to plans. A platform for which continuous improvement can be made. Reduce cost. Improve quality. Basis for training. Then method capture current state. Calculate tag customer demand 90 units a month and time available 20 days a month. Tag available time by customer demand. Calculate 20 days divided 90 units. So into 24 hours in a day. So tag time equal to 24 hours. Current state operation 3 tag 24 hours. Then total wire content, line balancing ratio, line balancing efficiency. Then method capture current state. Method capture current state. Calculate tact. Time the process. Why videos? Used to visually record activity. Why video? Used to visually record activity. Accurate method of recording. Irrefutable and unambiguous modern approach to establish method. Capture a representative sample of the process. Review the video with the operator present. Break down the elements of work and record a time for each one. Identify which of the elements are value added and which are the elements of the non-value added. Then automatically you can know. So method capture state. Calculate tag time. Time is the process. Break down the work elements. So the operator cycle time is broken down into the elements. And these elements are put into the three main categories. Those are working, a man or machine, working, waiting. So this graph will show in everything, and then you can manage. Method capture for current state. So calculate tact, time the process, break down the work element, draw current state, line balancing. So see that one, that image and the graph. Then constraint minus customer demand not being met. So calculate total wire content stacked. Equal to 15 plus 13 plus 7, 62 hours. Then operation 3, Takt to be 24 hours, total work content 62 hours. So what will be like? Then line balancing ratio, where measure capture the current state. Or alternatively, identify the business area to be balanced. Machine 1, treatment, then assembly. Then instead to form small group with team leader or operators. So step 3, you break down each process by tasks. Use post-it note, write on the process name, place on a board in sequence. Operation on number 2, the main process step, then a sub element of the bar. Then step agree, estimated time for each job and the number of operator is involved. So estimated the time for each submit, add up all the element, write on the main post it and the total time of the total operator. That is 1 for 10 hours use rough guide. Number of operator, total estimated time. So that will calculate. Method capture current state. Calculate time of the lay all the post-its out in sequences so that all the processes are visible. So draw on the track line or use string. So takt equal to this capture current state. Target manpower equal to total work content divided by takt time. Then total work content 62 hours divided takt time 24 hours. Then 2.48 into 3 operators. And then automatically coming and method capture for current state. So line balancing efficiency, line balancing ratio equal to total work content divided by number of station into longest operation. So calculate takt time, time process, break down the work element, draw current state line balance, calculate target manpower, and calculate line balancing ratio and efficiency. Uh, Line balancing efficiency equal to total work content divided by target manpower into time. So line balancing ratio equal to 62 hours divided by 3 into 3 into 100, 69%. What could be the achieved without reducing waste and still meeting tact? Minus simple real balancing. Then line balance equal to 83%. Method balance to tact. Method balance to tact. This is the example and this video will clearly show that how to manage the tact. Method balancing of tact. So method balancing of the tact. So first one is identify the element of work that exceeds tag, identify the element of work that exceeds tag, and refer to standard work combination table. Identify where the work can be relocated and or method for the method of balancing of the tax or alternatively refer to the post-it notes on the web using magnetic strip and signify the post-it and notes element of the time using the experience of the team or leaders operators invite them to rebalance the work to below tagged. So modify method. Identify value added and non-value time. Identify value added and value adding. So any process that changes the nature, shape and characteristics of the product in the line with customer requirement. Example, machining and assembly. What is the value added non-value added? Non-value added adding but non-value adding but unavoidable with current technology or method. Any work carried out that does not increase product value. Example: inspection, part movement, tool changing, maintenance, and waste. And don't forget waste. All other meaningless, non-essential activity that do not add value to the product and it can eliminate immediately. Example, looking for tools, waiting for time. Methods. Identify value added and non-value added time. The traditional focuses. So work longer, harder. So it's work longer, harder and faster. Add people or equipment. So in lean manufacturing, improve the value stream to eliminate waste value added. Traditional work longer, harder and faster. Add people or equipment. Lead time. Methods and reduce non-value added time and eliminate waste. And see that image. That method and reduce the non-value added time and eliminate waste. Method balance Takt. Method balance Takt details each process step by step format above indicated what is the work, weight, work and work. Now we can split the operation on the board into the eliminate of the value added and non-value added work. Method reduction the non-value added time and eliminate waste. So highlight of the value added which highlights the value added and non-value added work element on the line balancing board, and that one red one is non-value added activity, green one is value added activity. Use the red strip to signify non-value added activity. Same thing, that is the method non-value added time and eliminate waste. Reduce the non-valid activity by applying waste removal tools or change over reduction, 5 base process mapping, etc. With attack on the red distribution, the green it. Relocate and rebalance. Relocate and rebalance. Tractor 24 energy operator feed up to the other process or improvement team. Method after the calculation line balancing ratio equal to total work content by the number of flow station into longest operation. Line balancing efficiency equal to total work content divided by target manpower into Takt. So that will so the line balancing ratio will 44 hours divided by 2 into 24 into 100, 92%. Previous balance ratio equal to 69, improvement of 23%. Method continuous improvement. So PDC cycle, PDC, plan do check act, continuously use waste elimination tool, value and waste. Method standardize, capture the new layout, indicated how the workflow, highlight key information. See that image you can understand clearly. Then method first standardize. You can standardize in and create one by one operation. Visual management. So the new line balance chart should be displayed on the cell, and the impact of the change in resource or tact and operator cycle times can be seen instantly. An opportunity for Kaizen activity can be easily identified. And then summary of the line balancing. Summary of the capture the current state, and after balancing Takt and eliminate waste. Capture current state. Operator 3, takt time 24 hours, total work content 62 hours, line balancing efficiency 69%, line balancing ratio equal to 83%. Then calculate takt time, the time process, and break down the work element from current state, line balance, calculate target manpower, calculate line balance ratio and efficiency. Then balance to the takt and eliminate waste. Eliminate waste. So first balance the task, reduce the non-value added and eliminate waste, and relocate the work and to rebalance, update calculation. Can this be improved? Yes or no? No means again. Yes means yes. Then you can reduce the non-value added activity. No means then simple complete the work instruction and standardize and implement. Future state equal to operation 2, tag to 24 hours, tag to work content 44 hours, line balancing ratio equal to 92%, line balancing efficiency equal to 88%. And this is my part 2 completed. And then let's start about the my part 3 video. Part 3 video, and then that video I will clearly explain about that. Okay, let's start about the line balancing and how can you achieve in line balancing. How can you achieve in line balancing? So line balancing we will explain. And first there, takt time equal to available production time per day divided by customer demand per day. Example 27,600 second, 480 plus 60 second. Then line balancing. What is line balancing? Line balancing is one of the most power tool in production. This tool covers balancing operator and the machine time to match the production rate to the takt time. In the production process, if the cycle time is less than takt time, the process is sufficient enough to keep the customer demand and line is perfectly balanced. Otherwise, if the cycle time is more than takt time, the process is not sufficient enough to keep the customer demand and the line is not balanced. This process stage is called bottleneck activities. Then how can you achieve the line balancing? So step 1, calculate takt time. The goal of the line balancing is to match the production rate to takt time, and so you can need to aware your takt time is essential. Takt time is the rate at which parts are product must be production in order to meet the customer demand. Example, takt time equal to available production time per day divided by customer demand per day. Example 27,600 seconds divided by 480 plus 60 seconds. So how can you achieve line balancing? In step 2, perform time study. The goal of the time study is to establish the time required to complete each task along a production line. You want to find out how long an employee and a machine spend on each part of a process. While it is possible to do time study with stopwatch and clipboard, there are now significantly better options. Manufacturer can now perform automate continuous time study, and thus the eliminating human bias and sample size effect. Then, how can you achieve the line balancing? Step 3. Identify bottleneck and excess capacity. In this step, you analyze the time study in your production line. Then find which process is longer than takt time and notice them. Also notice which parts are taking less than takt time. There is excess capacity in those processes. How can you achieve line balancing? How can you achieve line balancing? So step 4, relocate resources. Rearrange tasks to reduce excess capacity and bottlenecks. For example, move resources, workers and equipment from parts of the line that have excess capacity to bottlenecks. This will reduce the waiting waste in the places where there was excess capacity. It will also help improve production flow where there were bottlenecks. Try to organize eliminatory tasks into groups that minimize operator idle time and that maximize utilization of machine and equipment. Share the workload among operator in the most logical way, taking into account the data on operator performance that you can have gathered. Then step 5, make other improvement. Make other improvement. So the analyze of the quantitative data on your line will surely reveal the other opportunity to improvement that could improve the line balance on your lines. And to implement process improvement, You can manipulate three parameter: operator time, machine time, and setup time. For instance, you can give additional training to workers that take longer to complete tasks, or facilitate transition to reduce changeover times. You can also upgrade machine or make sure operator follow proper machine setup and maintain a standard operating procedure (SOP). Many lean practices can also help reduce variation in your line. 5S and visual management creates a coherent workspace, thus reducing the time waste looking for tools and improving process efficiency. 6 one is Pokayoka or error proofing, a process that helps catch defects early and which increases consistency of output. So this is my end of video for the three line balancing. So suppose uh, we can understand, then everything in this video. We will understand in everything and see that image also customer, how to happy in the customer business, respect for the people, team building, empowerment, training, and supplier relationship, and JIT flow, takt time, education, etc. So GTOK, Pokayoka, and done automation, 5-way quality improvement, stabilize and standardize. This will explain. So that's all up for me. So thank you for everyone for watching this video and support me. So thank you so much. Thank you.